how to calculate molar enthalpy changes from a heat energy change. So here's the question. The energy from burning 0.5 grams of propane was transferred to 100 centimetres cubed of water to raise its temperature, that's the temperature of the water, by 20 degrees C. Calculate the molar enthalpy change in kilojoules and then use this to calculate the molar enthalpy change in kilojoules per mole. So we're going to calculate the molar enthalpy change and then we're going to calculate the molar enthalpy change. So the first step is we're going to use Q equals mc delta T. So the mass of the water is 100 centimetres cubed and 100 centimetres cubed weighs 100 grams. So Q is 100 times by C, which we're told the specific heat capacity of water is 4.2. You'll be given this in the question or in a data book. Times by the increase of temperature, which is 20, and the increase of temperature is shown there. If you put this into your calculator, you've got 8,400, which is in joules, and let's convert it into kilojoules to make it a bit easier to use. So to convert from joules into kilojoules, we divide by 1,000, which is 8.4 kilojoules. In the next step, we need to calculate the number of moles of propane that we used. So to calculate the number of moles of propane that we use, we need to use the number of moles is the mass that we used divided by the relative formula mass. So the mass that we used we get from the question, and the mass that we used is 0.5. And to calculate the relative formula mass of propane, the relative formula mass of propane is all of the elements in propane added up by their relative atomic mass. So the RFM of propane is 3 carbons. There are 3 carbons. Each carbon weighs 12. So that's 3 times 12. Plus, there are 8 oxygens, and each oxygen weighs 1. Plus 8 times 1, which equals 44. So the relative formula mass of propane is 44. And we can then say that 0.5, the mass of the propane, divided by the relative formula mass, which we've worked out here, is 0.5 divided by 44, which equals 0.0114 moles. Now for the last part, we need to calculate the molar enthalpy change. So to calculate the molar enthalpy change, you divide the energy change, which is the enthalpy change, which is this number here, by the number of moles, which is this number here. So this is the enthalpy change, but we need to calculate the molar enthalpy change. To calculate the molar enthalpy change, you divide the energy change by the number of moles. So let's put the numbers in. So it's 8.4 kilojoules divided by the number of moles that we used, which is 0.0114. If you put that in the calculator, the answer comes out to be 737 kilojoules per mole. So the molar enthalpy change